So we learnt about these four basic kinds of reactions in classes. So a combination reaction, to remind you, is when we have two or more species combining into one. Okay, and by species, I'm normally talking about element or compound. Okay, it could be either. Okay, the idea is something simpler coming together into something more complex. Okay, decomposition is basically the opposite process, where it's one species breaking apart parts into two or more simpler things. So again, it can be breaking apart into elements or smaller compounds, that kind of thing. So then we have single displacement, or sometimes called single replacement reactions. Semantics, right? So that is when you have a free element replacing another element in a compound. So most commonly you'll see this, that you have a free element and then it will tend to replace the cation in a compound. That tends to be the most common way we see this happening. A double displacement, aka a double replacement, or a metathesis reaction, is when you have cation and anion partners swapping. Okay, so basically the cation that's originally bonded to anion A in the reactants then changes its mind, trying to anthropomorphize the cation, and then in the products is bonded to cation B, and vice versa. The other cation, which was originally bonded to anion B, in the products will be bonded to anion A. So let's have a look at the examples we've got here. We've got lithium as a free element, then HCl, hydrochloric acid, and then we have lithium chloride. So you can see what's happened here. The free element lithium has popped off the hydrogen and taken the chloride for itself. So that would be a classic example of a single displacement or single replacement reaction. So this is where, if you want to visualize, the lithium has come in here and been like, oi, you go away. Okay, and notice the balancing of ionic compounds. Lithium's group 1, so it's a +1 cation, chloride ion -1, and hydrogen's out on its arse over there. Okay, so then if we look at our next example, this is a pretty classic example of a double replacement. So our cation here is going to be lead 2, and our anion is the nitrate ion. Okay, and then in our second species, we've got magnesium 2+ and the iodide ion. And then over here, the magnesium 2+ is now bonded to the nitrate. Just keep an eye on the balancing, right? Nitrate ion is NO3-, magnesium is always Mj2+. That's how I knew that that was lead 2+, right? And then lead iodide, the lead 2 has bonded to the iodide ion. And look, you need 2 iodides to bond to balance one lead 2+. So that would be a classic example of a double displacement reaction. And then finally, we have potassium, the element, and fluorine, the element. Remember, fluorine is one of our homonuclear diatomic elements, likes to go around in the molecule, forming potassium fluoride. So that would be a combination reaction. So I'm going to just have a look and see what other examples we have, because we haven't seen a decomposition yet. So what else do we have here? Show me something else. All right, so top one here is a combination reaction. Then we've got a single displacement, and then we've got a double displacement. Still no decompositions. What is going on? Come on, show me a decomposition. Ah, here we go. Water breaking apart into hydrogen and oxygen would be a decomposition reaction. And just as an FYI, sometimes when you see decomposition reactions being written, you'll see something along the lines of a reaction arrow with, instead of just a normal one, you might see a delta sign above it, and that delta just means heat. So with the addition of heat, something decomposes, and that's quite common because often decomposition reactions happen at higher temperatures.